If you have robots or industrial systems that are communicating with Zenoh, and you want to persist a history of your data, that's what this video is about. So I'm Anthony from ReductStore, and first I want to show you what are the available storage backend for Zenoh. So you have S3, InfluxDB, RocksDB, and file system, but those are quite problematic if you want to store a history of your robotic data. S3, RocksDB file system, there are key value stores, so they can have one value for your key, and it doesn't store time series data, so it doesn't keep a history of your data. It's good if you need the last state of your network and your system. InfluxDB is a time series database, but it comes with limitations. InfluxDB works well for metrics like temperature sensors, yes, small records, but it breaks when the record is more than a few kilobytes. So it's not made for robotic applications or industrial IoT applications that wants to store log files, images, LiDAR, point clouds, and so on. So this is why we created a native API for Zenoh in ReductStore. And we realize ReductStore and Zenoh have the same principle. So a key in Zenoh is an entry name in ReductStore. A timestamp is the same. In ReductStore we use timestamps to index the data. The payload is what we store in ReductStore. Attachments can be stored as labels in ReductStore. So concretely, here is a small example that we'll go through to show you how we can persist a history of your robots. So typically we would have, depending on your application, we can have one ReductStore instance per robot. In that case, we have two robots that publish data on the Zenoh network and ReductStore that subscribe to that data. So here is the example. To set that up, you need here a simple compose file, local compose file. You need to have a Zenoh router running, and then you can use ReductStore. So ReductStore can be set up entirely with environment variable for provisioning your storage. And you can have, so first you need to enable Zenoh API. Then you can configure it either a string or with a file, configuration file. And then you can define your buckets. So here we'll see later in this example what is a bucket and an entry in ReductStore, but you can define how much data can be stored on disk. So you can define here a FIFO quota, for example 1 gigabyte, and when you reach 1 gigabyte, and it will automatically remove oldest blocks to make room for new ones. And you can also define where to store data from Zenoh, and here are key expression for the subscriber and the queryable in the ReductStore API. And so subscriber, you define exactly what ReductStore will persist. So ReductStore will create a subscriber that will subscribe to all topics that are under the robot's name here. And queryable, it's key expression that defines what ReductStore will answer to. So when I query through Zenoh network, I can define the key, and here the selector with start and stop, so you can define a time range, and ReductStore will reply exactly with that data. So to set that up, simply use docker compose up the build method, because we also, in the docker compose, we also have the robots that are simply publishing data to the Zenoh network. So it's example data with JSON telemetry data and images. So to see how that looks like, we can open the web console at ports 8383, and there you can see how ReductStore is organized. So you have buckets, here the fleet buckets with the FIFO quota that we defined in the environment variables, and each bucket can have different entries. Entries are data streams. So here you have data streams for the camera of robot alpha and the telemetry, and robot beta will also have camera and telemetry. if you look into each data stream, this is how data is stored in ReductStore. So every record has a timestamp, then it has some content. Here is an example picture, and it has a set of key value pairs. So those are the attachments from Zenoh. Status, okay, robot alpha, and we also store Zenoh source ID, so we know where the data come from, and the original timestamp from Zenoh. And that's as simple as it gets. You can set up ReductStore on your robot or as a central storage, and then simply have it to persist all your data from Zenoh. And then you can query either with Zenoh, with the get method, and in this method you can select the data you need, what key you need, but also the time range, and you can define here a when condition, which is a set of which is a conditional query, and you can filter data from ReductStore. So here you will get the data where the status equal warning. So this conditional query can be used everywhere. Give you an example here when I query the data. For example, if I query from the telemetry and I only want the data with status equal to warning, it will filter this data automatically for me, and each record will have the status warn here in this example. The content here is JSON. There are some extensions if you want to query those JSON data with data fusion and SQL queries. This is also possible. We have extensions for that, and you will need to go to this guide. So I can show you how that looks like. Redux extension, and you can define here your SQL query and export in the format you need, and so on. What is important to know as well is that you can also replicate data in ReductStore, and you can use the same conditional query. So a replication is simply a task that will push data to another instance in append only. So when you have new data coming in ReductStore, this replication task will look for this new data. It will look if it matches some condition, and then it will decide it will push it to the cloud, for example, in this example. It's configured like this. Here it pushes the data with equal when the status is equal to a warning, and this is the same conditional query you can use for querying the data. And for this example, it takes the source bucket fleet, and the destination is a cloud instance with the same bucket name. And often in robotic applications, the robot might be out of the internet connectivity might be unstable, and this is exactly what happens here in this example. Where the target is not reachable, it will simply wait and persist the data until the internet connectivity is up again. And when this is the case, it will push the pending records to the cloud instance. And that's how you set up ReductStore to persist data from your robots or industrial IoT applications. If you have any questions, you can come to ask on the community. We are active there and happy to help. The core of ReductStore is fully open source, so feel free to try it out and give us